In this class, I will explain about the concept of fluid pressure. So, as you know, pressure can be defined as the force exerted on unit area in general. So, here also, if you take a fluid, at some point within the fluid, if you want to find out the pressure, it is nothing but the force exerted by the fluid above that point per unit area. That is how the concept is. So here to understand the concept, I will consider a fluid or a liquid of specific weight gamma in a container like this. So I will take 3 points in this. One is A, which is inside the fluid. Another is B at the bottommost point of the container, and one point at the free surface. So this is the free surface. Free surface means on that surface only atmospheric pressure will be acting. That means it is exposed to atmospheric pressure. So in this case, you can see here the pressure at C will be equal to atmospheric pressure. 3 atmo means atmospheric pressure at that particular place. Then pressure at A here, at this point if you want the pressure, if this point A is at a distance of at a depth of h1 from the free surface, then pressure at A will be gamma into h1. From here to here it is gamma into h1, and we have to add atmospheric pressure to that, so plus P atmospheric. Then pressure at B at this point, if I take this depth as h2 from the free surface to this bottommost point B, then gamma into h2 is the pressure of this fluid or liquid at this B plus this whatever is their atmospheric pressure. So this is how we can compute the pressure at different points at different levels in a static fluid. This is static fluid because it is kept in a container. So suppose if the atmospheric pressure is taken as the reference or the datum. So if this point is taken as the reference or datum, that means you can take this as the reference. This P atmospheric as the reference. Reference means we can take it as 0. So above atmospheric pressure means it becomes positive value. Below atmospheric pressure means it becomes negative value. If you take that as 0, then what happens? This PC becomes 0 then. Because atmospheric pressure I'm taking as reference 0. PC becomes 0. PA becomes only gamma H1. This becomes 0. PB becomes gamma H2. This becomes 0. So now I can represent those pressure values in the form of a diagram called pressure diagram. So you can see here I have drawn the pressure diagram here. Pressure at C is 0, pressure at A is gamma into H1, pressure at B is gamma into H2. So if you join these three points, so this value is gamma H1, and this value, entire this value from here to here is gamma H2. So if you join these points by a straight line, because P varies linearly with H. So linearly with H. So that is why we can represent the diagram using a straight line. That is linear variation. It is a linear variation. So this diagram is in the form of a triangle because at the top part I have taken atmosphere as a reference and it becomes 0. So this diagram is called as the pressure diagram. If you find the area of this pressure diagram, so in a triangle area is given by half into base into height. So in this case it becomes half into pressure intensity, this pressure intensity into height. If you want the total pressure area of the pressure diagram. So in this case it becomes half into gamma H2. This is the base and H2 is the height. That means it is half into gamma into H2 square. This expression half into gamma into H2 square, it gives the pressure force acting on unit width. So you see here, so to understand about the units, so here we can see that this gamma is expressed in Newton per meter cube, whereas H2 square is in meter square. If you multiply these two, you are going to get Newton per meter. That is why it is called as pressure force, that is in newtons, acting on unit width, that is per meter. So this is the area of the pressure diagram gives the pressure force acting on unit width. That is the concept. Now pressure can be expressed, pressure of a liquid can be expressed in two ways. One in terms of pressure intensity, another one in terms of pressure head. So you should know the difference between that. So pressure intensity is denoted by P here. So this P is expressed in Newton per meter square, because once again here gamma is in Newton per meter cube, H is in meters. If you multiply, you are going to get in Newton per meter square, which is also called as Pascal. So Newton per meter square is called as Pascal. So here this intensity of pressure at a point can be expressed in pascals. So if the pressure is high, then you can express the pressure in terms of kilopascal, megapascal or gigapascal. So 1 kilopascal is 1 kilonewton per meter square or 10 power 3 Newton per meter square. 1 megapascal is 1 meganewton per meter square or 10 power 6 Newton per meter square. 1 gigapascal is 1 giganewton per meter square or 10 power 9 Newton per meter square. So the other way of expressing pressure is pressure head, which is nothing but this H. In this formula, this H is called as the pressure head, so which is expressed in meters, because it is P by gamma. P is in Newton per meter square, gamma is in Newton per meter cube. So if you simplify that, you will get in meters. So these two are the ways of expressing fluid pressure. One is in terms of pressure intensity in pascals or Newton per meter square, another in terms of pressure head in meters. Now, there are two important laws. One is the hydrostatic pressure law, which states that the pressure intensity at a point in a static mass of fluid is directly proportional to the depth of that point from the free surface. So that is P is directly proportional to H. So P is the pressure intensity at any point in a static mass of fluid, and H is the depth of that point from the free surface. So when this is as the depth increases, your pressure also will increase. That is the concept of this. So just to derive that or just to understand that explanation of the hydrostatic pressure law, we can consider a small element of a fluid, something like this, which has got an area dA on either sides. H1 is the depth of that area top edge from the free surface. H2 is the depth of the bottom edge from the free surface. And this distance, this height of the element, I will take it as that is H2 minus H1 as small h. And P1 is the pressure at this level, P2 is the pressure at this level. So these pressures are not same, they are different. So what I can do here is this P2 I can take it as P1 plus dP, where dP is the increase in pressure. Naturally, pressure at 2 will be more than pressure at 1, because 2 is at a lower level and more fluid is there above the point 2 compared to above the point 1. So this, let us consider this is a fluid element which has got a specific weight value gamma. Now what we have to do is we have to apply the equilibrium equations for this element of the fluid. So very simple. So the pressure should be converted to force. How to convert pressure to force? When you multiply the pressure intensity by area over which it is acting, it will be converted to force, because pressure is defined as force per area. Force will be equal to pressure into area. So here at this point, if I want the force acting, so it will be pressure P1 multiplied by the area dA. So P1 into dA is the pressure force acting at this level, and W is the weight of that fluid element, which is given by gamma into volume. Specific weight into volume gives the weight of that fluid element. Here volume is nothing but that area multiplied by the height, that is H. So H is nothing but H2 minus H1 I have taken here. So gamma into dA into H gives the weight of the fluid element. So weight and this P1 force, the pressure force at 1 will be acting downwards, whereas pressure force at 2 is acting at upwards. So P1 plus dP or P2 is acting upwards. And this is the intensity. When you multiply that intensity by the area dA, you are going to get the pressure force at 2. So now, if you write the equilibrium equation, downward force is this. This is the downward force. P1 into dA plus W is the downward force, which should be equal to upward force P2 into dA. Now, for W, you substitute it as gamma into dA into H. So, and if you simplify this, if you simplify for P2, you put it as P1 plus dP. If you simplify, this P1 and P1 will get cancelled. You will be getting an expression something like this: dP is equal to gamma into H. So this dP is for this small element. If you consider the entire fluid, then at any point in a fluid, if you integrate this, you are going to get the expression like this: P is equal to gamma h, where gamma is constant. So gamma is the specific weight of that particular liquid. So if you, this is the same as this, P directly proportional to h. If you introduce gamma here, so the constant proportionality is nothing but gamma here. So P is equal to gamma h. It is called as the hydrostatic pressure law. So the second important law is called as the Pascal's law. So in this Pascal's law, if once again in a static mass of fluid, pressure is same in all the directions. That means pressure at any point is same in all the directions. Suppose you consider a liquid. So I will consider a fluid element like this. So I will consider a, what you can say, triangular element, something like this. So I will take x direction pressure is like this, y direction like this, s direction like this, inclined. So according to Pascal's law, all these three pressures are same. Px is equal to Py is equal to Ps. So I am considering a point here. At that point, whatever Px is there, Py is there, Ps is there, or Pz, whatever it is, they are all same. That is the meaning of Pascal's law. So you can always prove that. You can refer to the book for the proof. Now, another thing is, we can always express pressure of one liquid in terms of pressure of another liquid. So very important. Sometimes some other fluid other than water may be used for calculating the pressure. In that case, you may have to convert the pressure of the given liquid in terms of pressure of water. So how to do that? So P is the pressure. Let us say I have to convert from one liquid to another liquid. So I will take gamma 1 as the specific weight of the first liquid, gamma 2 as the specific weight of the second liquid, H1 is the pressure head in terms of first liquid, H2 is the pressure head in terms of the second liquid. So in that case, since I want the same pressure to be expressed in terms of two liquids, so P is equal to gamma 1 H1 and that is also equal to gamma 2 H2. So please observe here, out of these four things, if you know any three, you can find out the fourth one. So normally, you will be knowing the two liquids, what are there. So you will be knowing the values of gamma 1 and gamma 2, and H1 you will be knowing. In terms of one liquid, what is the pressure you will be knowing. So you can always find out the pressure head in terms of the other liquid using this formula. For example, if H2 is unknown, H2 can be written as gamma 1 H1 divided by gamma 2. Maybe one may be water, two may be mercury or something, oil, something like that. The only thing is, you should be knowing the specific weights of those liquids and the value of pressure head in terms of one liquid. Then you can find out the value of pressure head in terms of another liquid. So this is how we can convert same pressure of one liquid in terms of another liquid. Now another thing very, very important, we can classify the pressures based on the reference. So that can be explained with the help of the sketch. Now if you observe this sketch here, I have taken two references. One reference is absolute zero. So this is reference 1, absolute zero or complete vacuum. Another reference is local atmospheric pressure. This is reference 2. So reference 2, reference 1. X-axis, you have two x-axis here. One is for absolute zero or complete vacuum, that is reference 1. Another is for the local atmospheric pressure, that is reference 2. So I will take 2 points here, A and B. I want to measure the value of pressure. So how to measure it? Let us see. I will take a point A here. So this point A is above this local atmospheric pressure line. Please observe here, above the local. So the pressure here is P atmospheric. That is mean number. Whereas the pressure here is 0. That is the mean. Absolute 0 means it is complete vacuum. So here I will have taken a point A above this local atmospheric pressure. Then if you take a point A here, if you measure the pressure of point A with respect to local atmospheric pressure, then it is called as gauge pressure. So this is called as the gauge pressure at A, PA gauge. Suppose at the same point, if you want to measure the pressure with respect to reference 1, that is complete vacuum or absolute 0, then the pressure will be from here to here, which is called as absolute pressure. So it is called as absolute pressure at A. This is called as gauge pressure at A. Same point, but we are expressing pressure in terms of two different with respect to two different references or datums. Now you can observe here that, so this is also positive because here I am measuring with respect to local atmospheric pressure, it is more than or above the local atmospheric pressure, it is taken as positive, and P absolute is also positive because it is above this absolute zero. So if the point is, if the point is above the reference point, it is pressure is positive. If the point is below the reference line, it is negative. So gauge pressure is measured with respect to local atmospheric pressure, that is from this level, whereas absolute pressure is measured from absolute zero or complete vacuum. You can express the pressure at any point in two different ways depending on the axis of reference. Now I will take another point B. Observe here that this B, point B is below local atmospheric pressure. Since it is below local atmospheric pressure, if you measure the pressure with respect to local atmospheric pressure, you have to move down. So move down means it is negative. Please note this. This is negative pressure. Negative gauge pressure. So gauge pressure at B is negative, gauge pressure at A is positive. But if you take the absolute pressure here, absolute pressure at B will be, you have to measure from this axis, it is positive only. So that means, in other words, negative gauge pressure is also known as vacuum pressure or suction pressure. So that is another unit. So gauge pressure can be either negative or positive. It can be positive gauge pressure or it can be negative gauge pressure. If the pressure at any point is above the atmospheric pressure, then it is called as positive gauge pressure. If the pressure at any point is below the local atmospheric pressure, it is called as negative gauge pressure or vacuum pressure or suction pressure. Normally in the case of pumps to lift water from the sump tank, so suction pressure has to be created so that sucking of water will take place and it delivers water to the higher level. So and another thing is, absolute pressure is always positive. Please note that here, even though gauge pressure at B is negative, absolute pressure is positive. So absolute pressure is always positive because it is measured with respect to zero, absolute zero. So in general, what you can write here is, absolute pressure at any point can be defined as, or it can be mathematically written like this, it is atmospheric pressure plus gauge pressure. If you consider point A here, so this absolute pressure is from here to here. So from here to here means it is atmospheric pressure from here to here plus gauge pressure from here to here. So this refers to point A in the figure. Okay. Or suppose if any point is below local atmospheric pressure, then you can define absolute pressure as atmospheric pressure minus vacuum pressure. So you can see here atmospheric pressure is from here to here. From here to here it is atmospheric pressure. From that I have to deduct this vacuum pressure, so that you are going to get the gauge pressure. So here I have to deduct, here I have to add. So if the gauge pressure is positive, we have to add that to the atmospheric pressure. If the gauge pressure is negative, we have to deduct that vacuum pressure to get the absolute pressure. So if I want this value, I have to deduct this from this local atmospheric pressure. So like this, these are the basic concepts of fluid pressure, intensity of pressure, and how the pressure varies with respect to depth. Then what about hydrostatic pressure law and Pascal's law, and how to express the pressure of one liquid in terms of the other liquid, and how the pressure is classified. So it can be classified into two types, absolute pressure and gauge pressure. Absolute pressure is always positive, whereas gauge pressure can be either positive or negative.